Carol and I are presenting about recycling manure from beef feedlots and to cropland and then rangeland. And so, as Jean mentioned, I'm at University of Nebraska, and Carol is now at Texas A&M Agrilife. And we have Pete Kleinman as well, one of our co-presenters, but he was not able to be here today. So first, we wanted to mention the context of this research. It's embedded within the long-term agroecosystem research network, of which there are 18 sites. And so far, there's manure shed work happening at 10 of those sites across the US. And that's not exclusively beef manure. So dairy, swine, poultry, and even biosolids. So one of the goals of the LTAR network broadly is to examine business as usual, or more of those status quo management practices, and compare those to more, supposed to be more sustainable, aspirational practices. And so the manure sheds working group is working at these where you see stars. These are sites that are working on manure management issues, including agri-food Canada, and they represent crop, integrated, and more rangeland systems. And the manure shed working group of the LTAR network really evolved out of this understanding that there's this historical uncoupling of crop and livestock production that Nathan Sayer mentioned in the opening plenary. And that kind of presents one of these great challenges facing the sustainability of modern agroecosystems. So recycling manure nutrients represents an important objective, and then recoupling those livestock and crop nutrient cycles. And if done prudently, this manure application has the potential to increase soil nutrient availability and support soil health, generally like regenerative agriculture. It'd be remiss without mentioning that there are potential concerns of manure application, particularly rangeland. We don't typically, that's not as accepted yet. Concerns being about phosphorus and nitrogen leaching and runoff, the impact of manure application on greenhouse gas emissions generally, how it contributes to soil carbon sequestration, and weed seed dissemination. So the manure sheds working group is, like I said, really working to recouple the crop and livestock systems and examine some of these cons and opportunities. So their objective is really to understand manure shed solutions across the US and Canada. And so as part of this effort, I interviewed some 10 of the 20 largest feedlot operators, largest being most head of cattle within the US. And Sherry, I apologize. I see you've updated this figure. So this is an older version, but and so we are working on a study that's in preparation right now, studying nutrient cycling, status quo being kind of that local manure nutrient recycling, and then comparing that to two hypothetical aspirational practices that would be more regional, so that those manure nutrients just traveling further. And then this scenario that's really national, international, where manure nutrients that originated on grazing, like cow-calf operations, are then returned. So, but currently from the interviews we conducted, and that was all mainly about solid manure management, I should mention. So not as much concentrated on liquid effluent. That's traveling even less. But the solid manure management is, staying kind of within 16 kilometers or even less, as this feedlot operator said, that manures may be traveling 10 miles, probably more like 5. And that was pretty consistent. And I should mention, this is all mainly application on cropland, just because that's kind of more of what's happening. And that's what, so talking to feedlot operators, I can, only talk to them about what's actually happening as opposed to applying to rangeland. So some of the barriers that came up, some that I don't have here would be just the phosphorus and nitrogen balance of manure, and so making that a more standardized product. Another barrier was only one of the feedlots, I think, mentioned this, but there not being enough cropland. So irrigated agriculture in their region is kind of disappearing, and there's less cropland, and their manure is having to travel further. Obviously, the barrier that came up the most frequently to just getting that manure to travel further away from the operation to nutrient sinks is freight. It's just a heavy product and currently not valued very highly. And another barrier that came up was regulation, as this U.S. feedlot operator from South Central region mentioned that, from their perspective, farmers are, they can apply as much commercial fertilizer as they want without having to fill out onerous paperwork. And that when they, if they take even a pound of my manure, I have to give them pages of paperwork and occasionally have them sign off on stuff and give us information. So there's a disincentive from their standpoint to take anything. As soon as they are regulated, they start to find ways to avoid it. And one of the ways to avoid it is to not take the manure. And they didn't just mention barriers. They also talked about opportunities and how they can see manure application being applied more broadly, whether that's to cropland or further afield to rangeland. And one of the things that one of the operations is doing is they have a compost days where folks come and basically load up their pickups and take off compost for just local gardens and yards. And, they're wondering, how do we go commercial on that? What are the regulations to get into maybe bagged manure products that would be sold at Home Depot or Lowe's? How do they get into that market? Something else that came up, which is kind of maybe market-based incentives, because that was one of their barriers, that when fertilizer prices are high, all of a sudden manure sounds, as this producer said, really damn good because you can buy it for $1 or $2 a ton. But when that fertilizer price is fairly low in those years, they have a hard time getting rid of that manure. So if there were some kind of market-based incentives for farmers to come and grab manure, then that might increase the utilization. And lastly, this isn't that surprising, but just increased technology in manure treatment and processing is something that could really increase transport distances and therefore sustainability, that recoupling of livestock and crop systems. This producer they're mentioning how valuable nitrogen and phosphorus is in, how valuable they are in our country, but that it's, we need more technologies to kind of pelletize or process that can help us to transport it further. And that would be something that anybody in their industry, from their perspective, would be interested in, is making that value-added product and making that a product that people are going to purchase, as opposed to an externality, something they have to get rid of. So now that I've been mainly talking about manure application on cropland, but there are also obviously feedlots proximate to rangeland. And so now Carol is going to talk about an example of manure application on rangeland and its effects on biomass production and soil health.
Thank you, Gwendwr. Good morning, everyone. So as Gwendwr mentioned here, I'm going to talk a little bit a specific study we are conducting in the rangeland in the northeast of New Mexico. Actually in the Clayton Livestock Research Center, that is one of the research centers of the New Mexico State University. So because of the importance of using and the conscience created this conscience about how important, and we need to use this manure in cropland and recoupling livestock production, regardless the livestock production, with crop, and regardless the crop we are talking about. So there's this opportunity for us, and we thought about Manure Shed Working Group has around 10 sites spread in the country. They are all evaluating different sources of manure. So in Pennsylvania, for example, they are applying dairy manure, but in Texas Gulf, they are applying a kind of beef manure processed. They are producing, they call as a biochar manure, and they are applying some crops and integrated systems. And we are seeing many opportunities to improve productivity, as well as improving the soil sustainability in the long term. And this is not different when we talk about rangelands, especially in our dry conditions, as here in New Mexico. And in general, we are seeing many effects of the climate change, and we need to pay attention on this. So what I brought today is just an overview of our first study in Clayton. So before I started with Texas in Agrilife, I was based in this research center. There we have a feedlot with a capacity for about 1,000 animals. So, and we produce a lot of beef manure. So what we can do with this? And we have rangelands around our research center. So we thought about to set up a simple and a first experiment in our area, applying, just compare control with one rate of beef manure. And this rate, about 54 kilograms per hectare, this rate of beef manure came from these two studies developing in New Mexico State previously at the beginning of 2000 years by Cabrera and Esteves. But in these studies, they applied dairy manure in rangelands close to Las Cruces. And they saw many improvements in soil conditions as well in biomass production. But it's important to highlight, I think it was Cabrera that evaluated a high dose of dairy manure that impact negatively and causes many, they decrease biomass production, for example, and they didn't conclude that the high dose was good. So I decided not apply a high dose in our site. I just picked the low dose that they saw good results. So it's a promising, I can call as a promising recommendation for rangelands. So what I'm doing there, I established 3 blocks, no manure, with manure, and we are applying every summer. So this past summer was the first time we applied beef manure in these areas, and I'm starting tracking soil and plant vegetation. So this is just an overview of our area. And about the beef manure, the other important point, as Gwendwr mentioned, it's the importance to create and develop new manure treatment systems. When I realized how I can spread homogeneously manure in this area, so I start take some beef manure from the stockpile, and I realized it's impossible to spread beef manure homogeneously in this area. And since it's an experiment, a field experiment, I should be very, I should have a control about this area. So I bought a kind of an equipment that you can grind mulch, but I started grinding beef manure. So I could have this manure very, at least in the same size. And the amount applied in this area is about, because my plots have just 100 square meters. So I apply about 53 kilograms per area. But if you wanna see in a great area, for example, when we talk about rangelands, it's about 2 2 tons per acre, or 5,300 kilograms per hectare. And as I mentioned, we are going to apply every year. And unfortunately, I don't have like more results, but this is just a baseline data. But it's important also to bring today because we can realize from where we are starting. So in our area, we have an overall average about around 1 tons per hectare. So one of our hypotheses is we are going to improve our biomass production over time if we keep our application over every year. This is one of our hypotheses. And the other one is about the nutritional composition. I brought these these few variables, but the important crude protein from this native pasture is around 7%, and total digestible nutrients, it's 50%. It's not fair compared with hay, for example, but I brought this table just to have an idea of how we can improve our material. So if you see here, USDA classified according to the price and the quality of this material. So if you see here, our native pasture would fit on this utility hay. So I think there is possibility to improve for the quality, and we'll see next year at the end of the summer. And the other important point is about, can we create intensified plots around rangelands? Because our idea, we know spreading beef manure in rangelands is not a common practice. We know crop producers tend to seek manure more than rangelands. But can we, if we apply consistently and in a prudent rate, can we create intensified plots to alleviate our drought conditions or low levels of biomass that we are seeing in the New Mexico state, for example? So this is some points, important points from this project. And yeah, and the other interesting piece of our project is about the soil health indicators. We are evaluating some of the variables, and all this analysis was run by following the comprehensive assessment guidelines created by Cornell University. They have a robust and standardized protocol to measure soil health indicators. So using this approach, we are able to compare with different sites, since we are talking about a multi-site project, and we got good results. These soil samples were collected just 2 months after application, and it's a preliminary data because I'll keep my soil sampling over the seasons. So, but you can see, especially for labile fractions, because one thing is important also when we talk about soil health indicator, because most of the people thinking about soil, total soil carbon or total soil nitrogen, but these 2 variables are very, they change slowly, or there depends on the management practices. They demand more time than the labile fractions. For example, the soil protein here and the active carbon, they means labile fractions. What this means? This means a kind of a carbon compound in the soil systems that the microbials can access easily in a short term. And it's a prompt energy source for the microbial community. So this is an important evaluation. And you can see here, manure versus no manure application, they had good difference. There's no statistical analysis here, but we can see for the active carbon and for the soil protein. But for total carbon, total nitrogen, the difference is not very high. So this sounds to me that we can see good, interesting results over season. And I'll track these, and probably next year I'll be here again. And also, I highlight the aggregate stability, soil fertility, and soil pH. That is considered a soil fertility variable and water capacity. They are all included in the soil health package, and they are important indicators for us if you think about like keep soil sustainable over long term. And let me see. Oh, another important, I think I can't call as a hypothesis, but one of our expectations is that if these projects had at the end good results, this is important because we are hearing a lot about soil carbon sequestration, carbon market, but we don't know how much costs for the ranchers, how much costs or how the profitability of having or using sustainable practice management in the ranchers. So this is something interesting from this project. And lastly, our conclusions. Currently, manure is distributed on primarily cropland, proximated to feedlots, and to increase the travel distance of manure, we need technologies and market-based incentives and potentially regulatory changes in different areas. And the two main points from this part of the project is that we can provide science-based information for beef producers, ranchers, extension, specialists and regulators to protect soil, plant diversity, air quality, and management feed yard manure, and enhance the efficiency and sustainability of cattle production, especially on the establishment of beef manure sheds involving rangelands as a receiving lands. I have just 1 second. I think I forgot to mention, but we are concerned about bringing beef manure to rangelands and disseminated weeds, for example, or create some kind of vegetation shifts, not of interesting for us, because we don't want to impact negatively rangelands. We don't want to create more problems for the ranchers. We just want to improve our systems and produce more and keep soil sustainable. Yeah. Thank you so much.